Now, once we've calculated sort of where the center tends to be, and I could have spent a lot more time on that, but I want to give you the overview. What we're going to do is we're going to look at the spread measures. This means how spread out is a set. All right. So, just like when we talk about finding central tendencies, it's sometimes difficult to talk about for the exact same reasons, to talk about how big of a set is how big a set is spread out. For instance, if we have 1,000 people who make a salary of $40,000, and then Bill Gates walks in, well, if we just took the high and the low, it's going to look like a huge gap. All right? Whereas, really, my data is not very spread out except for Bill Gates walking in the room. All right? Most of it's real close. All right? Now, again, what we're doing is we're kind of looking at, I guess what I was talking about is the range. All right? The range is the distance from the biggest number in your set to the smallest number in your set. Take the highest, subtract the lowest. Okay? So, to look at range, it's a very straightforward calculation. All right? The high number minus the low number. So if Bill Gates walked in the room, let's say his high number was $200 million. Well, $200 million is pretty darn close to zero. Would be a range of $200 million. All right? Now, a second measure of central tendency is called the standard deviation. Okay? And notice, again, I have these X sub numbers. And what I'm meaning by these are just the numbers in our set. So this is X1 is the first number in our set. What you're going to do with that is you're going to subtract the mean. And whatever you get after you subtract it, you square it. You take X2 minus the mean, and you square it. And you keep doing that for every single number in your set, and then you add them all up, divide by n, and then take the square root. Okay. Now, I'm not going to get into this in too much depth, but it turns out that this comes from the distance formula. If you think about, let's say, a right triangle, okay, and this is 4 units and 3 units, and I want to find the distance. I want to find the distance from this point to that point. Okay, well, since we have a right triangle, I didn't draw it very well. We have the Pythagorean theorem, a squared plus b squared equals c squared. And this c is the distance, so technically c is equal to the square root of a squared plus b squared, right? And so the reason we get this sort of square root and something squared plus something else squared plus something else squared is because it's a distance from a constant set. That's what we're actually calculating when we're thinking about standard deviations. All right, and just to sort of re-emphasize that, let's say I have a set 3, 7. And instead of thinking about a set, let's think of it as an ordered pair. Okay, like on the Cartesian coordinate system. So we're at the point 3, 7. And I want to go to the point 5, 5. Okay, that's 2 units to the right, 2 units down. Okay. By the way, the reason I chose 5, 5 is because if you notice 3 and 7 average out to be 5. So if I was looking at the set 3, 7 has a mean of 5. All right. So what standard deviation does is it sort of gives us one way to calculate the distance between this point and this point, and then there's this weird dividing by an n, which takes precedent. So again, if I was to find the distance, what I would do is I would say c squared equals a squared plus b squared. So c is equal to the square root of. Now, I want to understand how I got the right triangle. We'll call this 2, let that be A. This 2 will let that be B. Okay? I want you to know that the A I got was really a difference between the 3 and the 5. So we could have written that as 3 minus 5 squared. So a squared is 3 minus 5 squared. B squared, well, that's 7 minus 5 squared. And now you kind of see the point, what we're getting as far as the distance goes. That distance formula is the one that we know and like. So here's what I want you to do. I want you to look at the range and standard deviation of the following set, 4, 6, 8. Push pause, try to calculate the range and standard deviation, and then come back and look at it. All right, hopefully you've gotten this, and I want to make you look deeper than what just the calculations are. So, range is the easier of the two things to calculate. Range is the highest minus the lowest. So in this case, our high was 8, our low was 4, so we have a range of 4. All right. All right, to get the standard deviation, we're going to have a big square root. Now, let me say something about this. The average here of 4, 6, and 8 is 6. So when I do the standard deviation, I'm going to do 4 minus 6, square it. I'm going to do a 6 minus 6, square it. I'm going to do an 8 minus 6, square it, divide by 3, and then take the square root of the entire thing. Now that's a fairly cumbersome thing to do. And by the way, modern computing power, if you have a statistical program, it'll do this for you automatically. But you should understand sort of what it's getting at and how it's getting the calculations that it does. So you take negative 2 squared plus 0 squared, plus this is positive 2 squared. Divide that by 3. Let me do this a little bit. So what you get is the square root of, this is 4 plus 0 plus 4 over 3. So the square root of 8 over 3 is the actual answer. Okay? Now, what I want you to do, this is going to be an ugly decimal form answer. And for the test or for a quiz, we're going to round that to maybe 2 decimal places here. If it says otherwise on the quiz about rounding, then don't worry. But typically 2 decimal places. Sometimes if it's a weird thing, we go to 3. But 2 is good for now. So I want you to calculate this on your own. Range and standard deviation of this set. Push pause on the video and calculate this on your own. Alright, so you should have calculated this fairly straightforward. Let me just write this down real quick. The range is equal to 8, And the standard deviation, you would do a 2 minus 6, square it, a 6 minus 6, square it, a 10 minus 6, square it, divide the whole thing by 3, square root, and what I got after I calculated it was about 3.26. Excuse me, if I round it correctly, 3.27. Right? Now, I want you to notice that the set 4, 6, 8 was a tighter grouping than 2, 6, 10. They both have averages of 6. But that last set was a tighter grouping. And because we had a tighter grouping in the last set, my standard deviation was significantly lower. All right. In fact, remember, if you recall, it was 1.63. So the more spread out a set gets, the higher the standard deviation is going to be. And by spread out, I mean each individual element. Now, this one's a little bit more cumbersome, but it's still doable as far as range and standard deviations go. Okay, so I want you to push pause and calculate the range and the standard deviation of this. All right, so hopefully you've done this. If you take the smallest number, 35,000, and the biggest number is 237,000, unless I've looked over something. The range on this guy is $202,000. Okay. Now, let me just state for the record, I was measuring salaries in dollars, so my range came out to $202,000. Okay? It turns out one of the advantages of dealing with standard deviation instead of some other spread measures is that it will in fact come out to dollars as well. All right? So whatever you're measuring in, if it was dollars, your range and standard deviation will both come back in dollars. If we were measuring in heights, my range and my standard deviation would both come back and do heights, meaning like inches or feet. Okay? So that's one of the very nice things about standard deviation. Now, before we move on, I just want to state for the record again, this is the same data set that we dealt with before. So when I calculate the standard deviation, my mean is 83,500. All right, dollars in this case. So in order to calculate the standard deviation, what you have to do is, and this is going to look a little bit ugly, but you're going to have to take 38,500, subtract off 83,500, square it. Do the same thing for 35,000. I'm just going to shorthand it up. Minus, maybe I shouldn't shorthand it. Minus 83.5. Square that. And you're going to do that 5 times. And maybe I should do a little bit of erasing here because it looks awful. But you're going to do that 5 times. And you're going to add them all up, divide by 5, and then take the square root. Now, if you haven't done that yet, then do that now. And we'll take a look at that after you've actually calculated. All right, so hopefully you've done that. Again, we're going to add up all these, a bunch of numbers. Divide by 5, all these numbers. Divide by 5, take the square root, and you should get around 77,309.77 dollars. Okay? So, add up a bunch of those numbers, divide by 5, take the square root, and then you get this big number, $77,309.77. And again, just for emphasis, the standard deviation, notice, is in dollars because all of our salaries were. Okay? There's some other, again, measures of spread that don't have this property. And so that's one of the many reasons why people tend to like standard deviations better.